looking at an American Standard heat pump package unit, and I kind of got a little bit ahead just because I went inside. It's not heating. I went in, turned the thermostat on, set the heat up, turned the fan to auto, didn't have any airflow. When I came out, walked around here, I could hear the contactor pulling in, pulling out. It'd pull in and it'd pull back out, going out on limit. So I've disconnected my call for the auxiliary heat just for that, because it seems like maybe we got a blower issue. But I've got 24 volts. On my Y. The compressor wasn't running and the fan outside wasn't running when I got out here. And I've got a call on 28 volts on G, and my blower's running. So it seems like the only thing that's responding to a call is these heat strips down here. Oh, that contactor pulling in and out. So before I hook those heat strips back in, we got to figure out why the blower's not running and why our compressor is not running. So I'm going to stick these little wire nuts back on these wires. I know they're alive, and we're going to concentrate on the blower first, because none of that other mess is going to do you any good if you don't have any airflow. So lay those screws down there. That's the upstairs unit that just came on. So I'm going to push the contactor in real quick on the heat strips just to make sure I'm getting amp draw on those when they come on. And, at least get that ruled out of the equation. Oops, sorry about that. Okay, so I got amps on my heat strips. So I know they will come on if that contactor closes, but like I said, without airflow, it don't matter what anything else is doing. So let's get the blower door off and figure out what's going on with our motor. Alright, so the motor that's in here is a PSC. It looks like it has a reverse direction, so there's been a universal type blower motor put in this unit. So I got to start tracing out some wires to see what's going where. And so let's see. These are going to be unused speed wires. Low, medium, high. This white wire coming off of these universal motors is typically going to be your common. And they have that wire nutted to my black wire here. Which is, let me find this wire real quick. So I've got that wire nutted to this black wire right here, and that is feeding over here to the bottom of my contactor. And that's common. It's going over here at the bottom of the contactor. So there you have our speed wire here, wire nutted to this purple wire. There. And that's going over here. And then the wire it's connected to on that block is our red wire. Which is going to our relay right there on our blower board. And then that red wire coming off the relay, that other one is going to be coming from the other side of the contactor. So that gives us our common and our speed. So now, is that relay back there closing like it's supposed to? So let me energize G and find out if we don't have a problem with the good old Trane time delay blower relay. That thing right there. Okay, so I've got my G jumped out right there. So let's see if we've got 24 volts going to our relay back here. And we'll just go to a ground there. Alright, so I do have 27.9 volts going to our good old Trane time delay relay. So if that relay is closed, the red wire coming off of it would come back here to this terminal. They put this little jumper block in here. So this one's coming off my speed to the motor, this purple one. This one's coming off the relay. The bottom of the relay is plugged to our contactor, getting a leg of power. So when that relay closes, it sends that leg of power over here back to our motor on the purple wire, and we already have our neutral over here on the contactor. So in theory, I should be able to go between this wire and this side of my contactor and get 240 volts. So let's see how that works out. So I'm going to get my needle probe or my one up in there, and then I'm going to go across here, and I have 0. So I should get 240 between these 2 points right here. This is going to be my L1 and L2 basically. And I'm getting there on the meter, whether you can see that or not. Getting 0. Now if I go to ground, I'm going to get 122 off that, but that's going to be my common back feeding through the motor to this wire, waiting for that other leg of power to meet it to get 240 volts and turn that motor on, and we are not getting that. So another way would be to just pull the wires off that relay and check continuity on it and see if it's closed, and we will do that real quick. So I'm going to there we go. See, that happens. You go in there playing, you vibrate it or bump it. I bumped it with the tip of my pliers. Gonna get the wire off of it, and the thing closed and the blower came on. So we figured out our blower problem. I got to replace that relay, and I'm guessing maybe this over here is locked out on some kind of pressure fault, maybe. And we'll reset everything and see if it all comes back on. Alright guys, so we're going to replace that relay back there with one of these, and it's pretty simple to do. What you have to remember is with most of these Trane units, when they're using contactors, the older air handlers for the heat strips, most air handlers, when the sequencer closes for the heat strips, it back feeds a leg of power to your normally closed part of this switch, which is where your blower speed is, to run the blower when the heat sequencer closes, or if it gets stuck, to make sure you got airflow in those situations. Trane does it differently. They use the top switch on this relay to send that leg of power to the blower, basically, or that relay that's in there, and then it also proves common to the contactor. So if you're going to replace it with one of these, obviously you're going to put your commons over here, your G over here. Your R's are just going to get wire netted together, or you can use an inline fuse. This unit already has a fuse in it. But energize the relay with your commons and your G, and then when this thing energizes, it's going to close, run the blower, then this switch is going to close, and then it's going to prove common to the contactor. That way when the contactor gets 24 volts on your hot wire for your auxiliary or your emergency, it'll close. But it prevents the heat strips from coming on as long as this relay is not closed. So you can send 24 volts to the contactor on the heater all you want to. If this relay is not energized running the blower and proving common to that contactor, the heat strips won't run. So that's what Trane does, unless the contactor sticks closed, to keep their heat strips from being on without having airflow. Close the relay, energize the motor, prove common to the contactor, and then when 24 volts gets sent to the contactor in auxiliary, it has common, it'll close, and the heat strips will run. So we're going to swap this out real quick. Alright, before I get this unwired, just to explain to you, some of you will remember the old Trane relays. It was one of these 9340 relays, but it had the little circuit board mounted at a low voltage. These were the updateds, I guess, or the newer versions. You don't see these anymore. But you've got your commons, your blue there, 24 volts. The only reason 24 volts is feeding this is to power the relay for the time delay in it. They're going to lose their time delay. It is what it is. It's an old unit. We got to get this thing fixed. But this orange wire is your common that feeds back through down here, back into the heat strips, and then it goes through the temperature limit and then comes back to the contactor. So that's kind of what this does. It closes this relay to send common to the contactor and closes this relay to energize the blower. So that's the way they keep the heat strips from being on if the blower's not running. So anyway, all we're going to do is kind of rewire this. I'll show you that here in just a minute. Alright, so basically what I've done is taken the R's that powered the old relay there, and I just wire netted those together. I already have a fuse in line over here. I don't need to put an inline fuse there. Put my blower speed on switch number 1. Put my line voltage in over on the other side, so when that switch closes, blower runs. I ran one of my commons to the second switch. Ran the common coming to the contactor for the heat strips on this switch, and then on the low voltage coil I put my G and my other common. So when that relay closes, it'll prove common to the contactor for the heat strips, and it will power the blower. So let's test it out and see what happens. Alright, so I've turned on the breaker for the transformer, compressor, blower. That the heat strip breaker is still off until I get through testing this stuff to make sure it works in the right sequence. But I'm going to use my jumper king here, which is just a bunch of wires wire netted together. You can jump multiple things out at once. So what we're going to do is I'm going to hit R. First thing I want to do is energize my blower, make sure my blower comes on. And we have airflow. Next thing I want to do is energize my heat strips. See if that contactor closes. It lets me know I've got the common circuit tied into that relay correctly. Get it? So you can hear the contactor closing. There. So I know my contactor will close when that relay is energized. Now I'm going to de-energize the relay, and this contactor for the heat strips should open back up. Yep, and it did. So that's how you check to make sure you have that wired up right. Now that we know we have that problem squared away, let's see if we can get the compressor to come on. And it just did. Contactors in. There we go. Compressor's running. And that's all it was, guys. Little old relay. Appreciate you watching. Like, subscribe, and we'll see you on the next one.